Okay, I'm coming back to the covariance matrix, and there we go, and we're already on part E. We're going to complete the covariance matrix by linking the non-zero cells and using the equals transpose function to replace the blanks. And I'm going to show you how to do that because we're going to use that again in the project later on, and it's going to be very important. Not much later, in fact. So what I'm going to do is transpose these. Remember I said that this is sort of the mirror image of this section down here? So I need to do it where this is here, this is here, this is here, and this is here, right? So the easiest way to do that, I could use the copy-paste special transpose like we just did in the last part, but I want to show you how to use the transpose function so you'll get used to it. So I'm going to select all 4 of the cells that where the resulting matrix will appear once I transpose. So I'm going to select all 4 of those, and I'm going to type in equals transpose, and I'm going to select this array, those 4. I'm going to close parentheses, and then in order to get the matrix function to work, I have to hold down Control and Shift and push Enter. Otherwise it doesn't work. I know. Excel did not tell us that, and it really doesn't even tell you that in the help functions. And you have to look at the question mark up here, the kind of in-depth help function to get that information. So I'm going to transpose this one here, close parentheses, hold down Control and Shift, and push Enter. Whoops. I did it for too long. Oh no, I have an extra parentheses. Okay, hold down Control Shift and push Enter. Then I'm going to put here, I'm going to do it again. Transpose those. Close parentheses, hold down Control Shift, push Enter. And this one I'm not going to transpose, I'm just going to get it. There we go. So now I've got the whole covariance matrix. I'm going to need it because I'm going to use matrix multiplication like I described in the lecture video to calculate the portfolio standard deviation. Okay, so next, so we're on part F. So in the row below the sigma matrix, we're going to call this the sigma matrix because it's the variance covariance matrix. I'm going to create a row for the weights of an equally weighted portfolio of stocks. I'm going to call this W prime because it's actually the inverse of the transpose of the weight matrix in the formula that I gave you on the slideshow. That I'm going to give you in the lecture video, which I actually have not yet recorded. Okay, so this is going to be the W prime vector. I'm going to fill it in with 1/5, so 0.2. And here I'm going to have the W matrix, which is the transpose of the W transpose matrix. I know that sounds weird. And I'm going to use the transpose function to get those values. And if you don't do that, you're going to have a problem in the rest of the project. So we're going to do equals sum. We want to use this. We're going to sum the row so that we can have a check figure to make sure it adds up to 1 as we change the weights in the portfolio, the weights of the assets in the portfolio. Okay. So now we're on part G. Part H. We're going to the right of the weights, we're going to create a column of expected returns by using the transpose function. It's okay. And I'm going to use the equals transpose function to go over to the returns spreadsheet, and at the bottom where it's the arithmetic average, I'm going to take those 5. Control Shift Enter. And it gave me my expected returns. Okay, so now I need to do W prime sigma, and I'm going to use this fancy symbol, sigma symbol. So I need to get it. So I go to symbols, insert symbols, and I get my sigma, and I go insert. That's just in case you ever want to insert a Greek symbol or anything like that into your spreadsheet. So now I'm going to calculate W prime sigma. Now, since I want a 1 by 5 matrix here, I'm going to select a 1 by 5 matrix, and I'm going to use mmult, and I'm going to multiply this 1 by 5 matrix by this 5 by 5 matrix, and the result matrix will be a 1 by 5. So then I'm going to make this table that looks something like this. I'm not sure I like this title. I'm going to change it for later. Expected return is going to be the expected return on the portfolio, not on the stock. Standard deviation of the portfolio, and the variance. And that's what's going to be here. So, the expected return of the portfolio is equal to the sum from j equals 1 to n of the weight in j, stock j, times the expected return of stock j. And what we're doing is we're using the past returns here, maybe not a great assumption, the arithmetic average of the past returns to proxy for the expected return in the future on security j. So we're going to calculate the expected return on the portfolio as this matrix times this matrix, and that's, so I'm multiplying a 5 by 1 by, excuse me, so I'm multiplying a 1 by 5 by a 5 by 1, so the result matrix will be a 1 by 1 matrix. Okay, so these two outside be a 1 by 1. So when you use matrix functions in Excel, you really have to think before you do them about what your result matrix is going to be. So in this case, it's a 1 by 5 multiplied by a 5 by 1, 5 by 1, which is going to give me a 1 by 1. So I don't need to select, I just need to select the one cell. Okay, so now we're going to calculate the standard deviation of the portfolio, and in order to do that, we have to calculate the variance of the portfolio first. So let me show you the variance of the portfolio from the slideshow you already know. So it's W prime sigma W. So we've already done W prime sigma, it's right here. It's a 1 by 5. And then we're going to multiply it by this 5 by 1, and the resulting matrix is going to be a 1 by 1, or a scalar like we expect to see for a variance. Then we're going to take the square root of that to get the standard deviation. So we're going to use matrix multiplication, and the resulting matrix is going to be a 1 by 1. So we don't have to select anything other than the ones. Close parentheses, hold down Control Shift, and push Enter. That's the variance of the portfolio. The standard deviation of the portfolio is the square root of the variance. I'm going to use the square root function, and then I'm going to check it to see if it's really the same. Therefore, net b is going to be percent with a couple of decimal places. And if I've done this correctly, the expected return will be equal to the expected return on the portfolio that I calculated in the returns spreadsheet, and the standard deviation will be equal to the standard deviation that I calculated in the returns spreadsheet, and they are.